Hey everybody, it's Mr. Oaks. So today we're going to talk about slope, and this is one of those topics that always seems to get my students really confused, and that in itself confuses me because I've always found slope to be relatively straightforward. Uh, but you know, everybody has their difficulties. So we're going to talk about slope today, and when we talk about slope, what we're talking about is the measure of the steepness of a line. How much is it angling up? How much is it angling down? Is it only a little bit? Is it a lot? And you can always think of it as like a mountain. Like, is it going to be easy to climb or is it going to be difficult? Do you have to slow yourself down? What's going on there? Now, the easiest way to think of slope is what we call rise over run. So how much do we go up or down over how much we go left or right? Now what I have here is a graph. I have a number of items, time in minutes. So maybe this is a machine that's making a certain number of items, and we got to figure out, well, how many is happening in a certain amount of time. So what we can do is we can choose 2 points on the graph, on the line, and we can then kind of create a little triangle and figure out the height and the width of the triangle. So I'm going to choose a point. Really, it doesn't matter because any points along the line are going to work. So I'm going to choose right here. All right. So that's at 420. Okay. And then I'm going to choose, it's right here. That's 9:45. And then what I'm going to do is I'm just going to, like I said, I'm going to drop a line down from one point, and I'm going to draw a line across from the other. And all I'm really going to do is I'm going to look and say, well, how much did it go up here? Because notice it's going up. So when we go up, that's what we call a positive slope. Okay, an increase. So as my x increases, my y is also increasing. So I look, and this goes up from 20 up to 45. So that's 25. And I'm going to put that on top. 25. So that's my rise. It rose from this point to this point, 25 items. When I look here, I'm going from 4 to 9. That's 5. I've got 1, 2, 3, 4, 5. So that's my run. So I'm going to go, and on the bottom, I'm going to put 5. So when we do this division, we always want our slope in simplest form. So it's going to usually be written as a fraction, and then we're going to try to simplify it so that it's, the number in the numerator and in the denominator, that they says they don't have anything else in common. The number that's on top is always going to be telling us how much we're going up or down. The number that's on the bottom is telling us how much we're going to the left or to the right. And that's why we don't usually change these things to decimals, because when we have it in the form of a fraction, the top number means one thing, the bottom number tells us another. As a decimal, doesn't really tell us much about the line. So when I do this, 25 divided by 5, I get a slope of 5. So for every 5 this goes up, it goes to the right 1. Okay, so that's one of the ways we can find slope. Not too bad, and that's kind of the easiest way to do it. It's very helpful when we have a graph and we can actually draw the lines here. Now, we're not always going to have the graph. So sometimes we're going to have points. They're going to give us points, but no graph. So our rise over run isn't necessarily going to help us, because without a graph, I can't draw my rise, I can't draw my run. So what do? Well, I have to reinterpret what rise over run means. So rise really just means the change in the y value, the change in our vertical movement. Run is really the change in our x. So how much we're changing from left to right. And the way we do that is we actually subtract, for the change in y, we subtract our y values. So the real slope formula, we use m to represent slope. I never remember why it's an m and not s or l or o or p or e or anything that's actually in the word. But I believe it comes from, I think, the French word for mountain, monter, or which I think also means slope in French. Don't quote me on that. I didn't take French. I took French in 7th grade for a semester, and that's it. So don't quote me on that. But our change in y is the difference in the y values. Our change in x is the difference in the x values. And what's important is that whichever point you start with, so whatever point you're choosing your y value from, you also have to use that as your first x value as well. That's why we see y2 minus y1 over x2 minus x1. So this is basically, I have this is one point here, this is another point here. And I'll show that in the example. So we have find the slope of the line that goes through the points 2.1, negative 4.2, and 2.5, negative 5. So I chose some ugly numbers. I chose some decimal numbers because those, once a lot of students see those, they freak out and they go, I can't do that. Yeah, you can. So here's one of the things I like to do. What I like to do is I like to rewrite my points so that they're over each other. So 2.1, comma, negative 4.2, and let me put my parentheses around there, 2.5, comma, negative 5. Now, the reason I do this is so that I can kind of make a little diagram. So what I do is I draw a line straight up and down, and I draw a line straight across. So I kind of separate it into 4 different sections. And what I do is I go, well, my first number in each parentheses is my x variable. My second number is always my y variable. This one here is my first point. This is my second point. And now if I look at this, I can go and I can kind of go, here's my y, here's my 2, bring it together. My y2 is negative 5. So it's kind of a way for me to organize and be able to put stuff in this formula and keep it organized and keep things from getting mixed up. So I'm going to rewrite my slope formula. M equals y2 minus y1 over x2 minus x1. And then I'm going to go and I say, okay, y2, that's negative 5. So negative 5 minus y1, that's a negative 4.2. Negative 4.2. So I got my top done. Then I go x2, that's 2.5. Minus x1, that's 2.1. So see, I'm helping myself to keep things in order. Now when I do this, negative 5 minus a negative 4.2, the minus a negative becomes a plus. So what I'm left with here is negative 0.8. running out of room. On the bottom, 2.5 minus 2.1 is 0.4. Now when I do this, I've got a negative slope, so m equals negative, and then 0.8 divided by 0.4, that's 2. So my slope for these 2 points is, for the line, I should say, that contains these 2 points, is a negative 2. So this is a line that starts up and angles down. That's what happens when we have a negative slope. Okay? The last thing we usually do when we have slope is we have to determine, well, what the heck does that actually represent? What does the slope, in a sense, mean? So we have to interpret it. So I have here, and I'm actually going to bring it up a little bit. A little graph representing calories burned. Okay? Someone's going for a jog or a bike or swim or whatever, and they're burning calories and they're keeping track of what's going on. Along the left-hand side, along the y-axis, or vertical axis, we have calories. So 10, 20, 30, 40, 50, 60, 70 calories. Along the bottom, we have the time in minutes. All right? Now, I only wrote the 2, the 4, the 6, the 8, but we actually have 1, 2, 3, 4, 5, 6, 7, 8, and so on. I usually will skip, because sometimes if you try to write all the numbers in a graph, it gets too crowded, and sometimes you get all confused, and you might double up on a line, or you might completely skip a line. This way, if you kind of jump, you know, you make a little mark, then the next one you do the number. It's a little bit more organized. So the first question I have is, what is the slope of the line? I have a graph. I'm going to do the easy thing. I'm going to choose 2 points, and I'm going to do rise over run. So I'm going to look, and I go there, 660, and I'll actually write that down so we see it. That's 660, and let's do, you know what, I'll do this one. 220. And again, I'm going to draw a line, a little dotted line from there, and another dotted line going to the side. And I'm going to take a look at my X, my Y values, my vertical, and I'm going from 20 and I'm going up to 60. So I'm doing 60, right here, 60 minus 20, which gives me a 40. So my rise is 40. Along the bottom, I've got a 6, I've got a 2. So 6 minus 2 is going to give me a 4. So I'm going to divide by 4. 40 divided by 4 is, we have a slope of 10. So great, we have this slope. It's 10. What does it mean? What does it mean in the context of the problem? Well, that's why we have to kind of look at what are our items, you know, our labels here. So we have calories for our Y value. We have minutes for our X. So really what this is telling us is that whoever this is who's exercising, they're burning 10 calories per minute. Because remember, the slope is actually our unit rate. It's our rate of change. It's our constant of proportionality. It's basically 10 calories every minute. So this person burns 10 calories per minute. And that's how we can determine it. So when we interpret, usually what we're finding is a rate. Okay, so we might find miles per hour, kilometers a minute, calories per minute. It all depends on the question, but basically we're taking whatever the label for the y values is and putting it over what the label for the x values are. Okay? I hope this was helpful. Slope really isn't that difficult, but for some reason it does seem to confuse people. Hopefully this was helpful for you. If it was, please like and subscribe. And feel free to comment and let me know what else you might want me to make videos about. All right? Okay. I'm Mr. Oaks. I've been doing some math for you. Everybody have a good day.